So we're going to start talking about the trapezoid rule. What we've done so far is we've talked about taking and making rectangles underneath a curve in order to use a limit definition to find the approximate area. Trapezoid rule just means you're making trapezoids, right? So you're getting a little bit closer to an approximation. You have a little less air there. So it just gives you a better approximation, and you can use this also when you can't take the antiderivative, like maybe it's a complex function, you just don't know how to take the antiderivative. So this is the trapezoid rule. Okay, so to find the integral from a to b of some function, first you're going to take b minus a over 2n. That's like this thing you're going to multiply by all this stuff. And all this really says is you're going to basically start at a and you're going to move in increments. Okay? And I'll tell you about the increments in a minute. But I want you to notice here it's 1 times this guy, 2 times this guy, 2 times this guy, 2 times this guy, and 1 times this guy. So it has this pattern of 1 plus 2 plus 2 plus 2 plus 1. So there's that pattern. Then you have this pattern of these x amounts, or x sub 0, sub 1, sub 2, and whatnot, are changing by delta x. And delta x is just b minus a over n. So you'll have n is whatever the number of trapezoids it tells you to do. So that just means I'm going to take my interval, b to a, or a to b, and subtract, so b minus a, and divide by how many ever intervals or trapezoids I'm going to do. So that tells me how much I need to change each x by, okay? And it'll make more sense when we get into a problem. And so this is just, I'm evaluating this function at those different amounts. That's all it really is. When I tend to do this work, I don't tend to do it linearly like this. I tend to do it more vertically just because it organizes your work a little better and makes it seem a lot less confusing. So you won't see me working horizontally, you'll see me kind of working vertically, just for it to be a little bit easier. All right, so let's take a look at the first example. We have the integral from 0 to pi of sine, oops, that's just say sine x, I missed my x. Sine x dx for n equal 4. So n equal 4 means that I am going to have 4 trapezoids. So my delta x will be b minus a over 4 or pi over 4. So I'm going to need to figure out f of 0, because that's where I start at, f of 0. Then I need to figure out f of pi over 4. I'm going to go move pi over 4 down. Then I'm going to move another pi over 4 on my interval, so that would be pi halves. And then if I move another pi over 4 down, that would be pi, 3/4 pi. And if I move another 4th pi down, that takes me to pi. And I can end there because that's where my interval ends. So I started at 0, and I keep moving by pi over 4 until I get to pi. Does that make sense? Because the rest of it just means I have 1 times this guy, 2 times this guy, 2 times this guy, 2 times this guy, and 1 times this guy. I'm going to figure out all those amounts and just add them all together. So then once I add all these guys up, I have to multiply it by that b minus a over 2n. Right? So b minus a would be pi minus 0 over 2 times 4, which means I'm going to multiply this whole thing by pi over 8. So I'll figure all of these amounts here, all of these. I'll add them all up, and I'll multiply it by that. So let's figure those out. So this is going to be 1 time, so it's not changing value, right? So it's just sine of 0. What's sine of 0? Just 0. So now I've got 2 times the sine of pi over 4. And what's the sine of pi over 4? Root 2 over 2. So I've got 2 times root 2 over 2, which is just root 2, or approximately 1.14? Is it 1.4? 1.4 or 4.1? All right. Now we have 2 times f of pi over 2. So 2 times the sine of pi over 2. What's the sine of pi over 2? 1. So I get 2. So now let's find 2 times the sine of 3 pi over 4. Sine of 3 pi over 4 is root 2 over 2, so that's root 2, or approximately 1.41. Then I have 1 times the sine of pi. Pi is 0. So all told, this is an approximation, so that's why I use a squiggly, is going to be equal to pi over 8 times 0 plus 1.41 plus 2 plus 1.41 plus 0, or 1.974 approximately. All right, let's take a look at our next example. So we're going to take the integral from 0 to 2 of x cubed dx for n equal to 4. So we know we have a couple of things to figure out first. First is our delta x, which is b minus a over n. So in this case, that would be 2 over 4 or 1/2. So that's how much we're going to be incrementing by. And then we have that number we're going to multiply that whole sum by is b minus a over 2n. So that would be 2 minus 0, or 2 over 2 times 4. So that would give us 1/4. All right, so I'm going to start with 1 times f of 0, 2 times f of 1/2, and then 2 times f of 1, 2 times f of 3/2, and then just 1 times f of 2. We'll add all that stuff up together and we'll multiply it by 1/4. All right. So we've got 1 times f of 0, that's 0 cubed, so that gives us 0. Then we've got 2 times 1/2 cubed, which would be 2 times 1/8. So is that 1/4? Yes? All right, so 2 times f of 1, so 1 cubed is 1, so that's just 2. Then we've got 2 times 3/2 cubed, so that'd be 2 times, what was it, 27 over 8? So 27/4. We could turn that into a decimal, right? I think that's 6.75, and this one up here is 0.25. Then we've got 1 times 2 cubed, so that'd be 8. All right, so we're going to add all these up. So 0 plus 0.25, whoops, plus 2 plus 6.75 plus 8. And multiplying that by the 1/4 gives us 4.25. All right, enough of the easy stuff. Okay. So the error formula says that we want the error to be less than or equal to b minus a cubed, so that interval length cubed, divided by 12 times n squared. Pretty straightforward. Then you have this gobbledygook here. All that says is it's the absolute value of the maximum of the second derivative. Okay, so to find the maximum of the second derivative, you're going to find where is the second derivative equal to 0. You also want to check the endpoints, and then you're just going to pick the biggest of those three numbers. That's all that means. So this is just the biggest of these three. That's all that means, just the biggest of those three. All right, so let's take a look at a problem. So use the error formula to estimate the error in approximating the integral, so that's like the part that I'm off by, with n equal 4 using the trapezoid rule of the integral 0 to 1 of 1 over x plus 1. So before we can calculate the error, right, we need to figure out first derivative, second derivative, so we can figure out that maximum. So I'm going to rewrite f of x as x plus 1 to the negative 1. It just makes it easier for me personally to be able to find the derivative. So then the first derivative would be negative 1 times x plus 1 to the negative 2. So then the second derivative would be positive 2 times x plus 1 to the negative 3, or 2 over x plus 1 cubed. All right, so we've got three things to find. This thing equal to 0, so let's do that first. So 0 equal to 2 over x plus 1 cubed. If you think of this as 0 over 1 and cross multiply, you would get 0 needs to be equal to 2. But it can't be, so I don't need to worry about that one. Second, I need to take the second derivative evaluated at a, or in this case 0. So I've got 2 over 0 plus 1 cubed gives me 2. Then I'm going to plug b into the second derivative. Here b is 1. So I've got 2 over 1 plus 1 cubed, which would be 2 over 2 cubed, which would be 2/8 or 1/4. First one we didn't need to deal with. So out of the value 2 and the value 1/4, which one's the maximum? 2. So we're going to use 2 for this piece right here. So this piece will be 2. So I figure out this and I just multiply it by 2. So let's figure out that piece. So my error has to be less than or equal to b minus a cubed over 12 times n squared. And in this case, n is 4. And then I'm multiplying it times that max number that we found to be 2. So it seems complex, but it's really not. So my error has to be less than 2, right? Because this piece would be 1 times 2 is 2, over 12 times 16. Or I can think about this as 6 times 16, which is that 96? Yeah. So I find that my error is less than or equal to 1/96. Whoops. What if we want to figure out what our n has to be so that we can be within a certain error? All right, first thing we need to do, so we have our f of x is the square root of 1 plus x squared, or I can write this as 1 plus x squared to the 1/2 power. So my first derivative would be 1/2 times 1 plus x squared to the negative 1/2 times the derivative of the inside, which would be 2x. So if I clean this up, my 2's cancel, and I end up with x times 1 plus x squared to the negative 1/2. So we're going to have to use product rule to find the second derivative. So derivative of the first is just 1 times the second plus the first times the derivative of the second. So that would be minus 1/2 times 1 plus x squared to the negative 3/2 times 2x. So let me just clean up that second term. And I notice my 2's cancel, and then I've got an x times an x, which is an x squared. And I've got this negative here, so that's minus x squared times 1 plus x squared to the negative 3/2. So do you notice you have kind of a common factor here, this 1 plus x squared to some power? When you have all these fractional exponents like this, a trick is to factor out the smallest exponent. So what by that I mean, I'm going to factor out that factor 1 plus x squared, and I'm going to do it to the negative 3/2. Right? If I have to choose between these two, I'm going to do it to the negative 3/2. Here's why. So if I divided divided this whole quantity right here, this 1 plus x squared to the negative 1/2, and I divide it by that same thing to the negative 3/2, what would go here? Remember what happens when you subtract, or when you divide exponents? Divide same base with the exponents, you subtract, right? I said that really awful. When you divide something with the same base, you subtract the exponents. So this would have to be in here 1 plus x squared to what power? Be positive 1, right? Negative 1/2 minus a negative 3/2 would be negative 1/2 plus 3/2. So that would be to, this would be to the first power. So since it's to the first power, I don't need those parentheses around it. Minus, I factored out this whole piece, so I just have this minus x squared left. What that ends up doing is this x squared and this minus x squared cancel, so I just have a 1 here. So I just end up with 1 plus x squared to the negative 3/2. Or you could write that as 1 over 1 plus x squared to the 3/2, your choice. So why did we do all that? Because we got to find that max value, right? So first I would set that equal to 0. That's the first step. I'm going to do it in this color. First we set this equal to 0. So 0 is equal to 1 over 1 plus x to the 3/2. If I think about this as being over 1 and I cross multiply, I get 0 is equal to 1, which is not true. So I don't have to worry about that one. That can't be a max. So next, I can find the second derivative at my endpoints, which are 0 and 1. So here's... You're right, I dropped that little 2. Those dang little exponents. Okay. So we figured this was 0, so I have 1 over 1 plus 0 is just 1 to the 3/2 power, which is just 1. And then let's figure it out. Is it 1? Is there other? Yep, 1. So I have 1 over 1 squared is 1, 1 plus 1, so that's 2 to the 3/2 power, or 1 over the square root of 2 cubed, which is 1 over the square root of 8, which is less than 1, right? So this guy is our max. Yes. All right, so I know that max is 2. So now I can actually figure out, and what are we told the error has to be? So it needs to be 0.001. Hang on. So my formula says, is it b minus a cubed over 12n squared is less than or equal to my 0.01. And I know b and a. So I know b is 1 minus 0 cubed over 12n squared is less than or equal to 0.01 is 1/100th. So here I have 1 cubed over 12n squared is less than or equal to 1/100. Well, I could multiply both sides by 100, right, to get rid of this. And then I could, well, I'll do that first. So I have 1 cubed is just 1. And then to get rid of this 12n squared, I can multiply both sides by that. In essence, what I'm doing is what you would call cross multiplying. But most people get confused because you're doing it over an inequality, but you can still do that. So now I've got 100 is less than or equal to 12n squared. Remember, I'm solving for n squared. So if I divide both sides by 12, I get 8.3 is less than or equal to n squared. And if I take the square root, I get 2.89 is less than n. Or the other way to say that is that my n has to be bigger than or equal to 2.89. So I have to use some subdivisions like bigger than that. So n equal 3 would give me an error that is less than 0.01.